Okay, thanks for the moderator, and now I'm Nia, and I want to continue the next material that is about the homogen and heterogen catalyst. So the first one is homogen catalyst. What is homogen catalyst? Is catalyst placed in same phase with reactant during the reaction. So it means that the phase is same between the catalyst and the reactant. For example, gas or liquid. But solid phase is not appropriate for homogen. It's appropriate for as a heterogen catalyst. We see here the properties is easy to decompose in high temperature because as we know that the particles in the form of gas or solid is very white atau lebar daripada than the particles in the solid. And it's difficult to separate from reaction mixture because we know that the phase is same, it's homogen, and then the reaction is really faster. For example, in here, to produce water and oxygen gas, we need hydrogen peroxide reactant. As a catalyst, we used bromine, but bromine for the reaction that used catalyst occur in two steps. The first one, 2Br- will react with 2H plus and then it will form Br2. After that, Br2 will react with hydrogen peroxide and then reproduce 2Br-. So in the final reaction, it will lose the catalyst. Buktinya bisa kita lihat di dalam kurva energi aktivasi, di mana dengan menggunakan by using catalyst, there are two form. Jadi ada dua garis yang tidak terlalu tinggi, garis lengkung yang tidak terlalu tinggi, which is not really high. Jadi energi aktivasinya itu sangat rendah, tapi ada dua garis lengkungnya. Dibandingkan dengan reaksi that happen one step, which is in the curve, garis lengkungnya itu tidak, line curve-nya itu tinggi sekali, energi aktivasinya tinggi, dan hanya terbentuk satu garis lengkung gitu, tapi dia sangat tinggi sekali gitu. Where we must use for this reaction, we must use catalyst. Then we jump into the next. This is about the second catalyst, heterogen catalyst. Is placed in different phase with reactant during the reaction. So it means that the phase is different if the catalyst in the form of solid, the reactant in the form of gas or liquids, like that. The properties in here, stable in high temperature, and then it's easy to separate from reaction mixture, as we know that the phase is different, it's the heterogen, and then it happens adsorption process. What's adsorption process? I will explain in mechanism reaction later. Let's see the example in here. To produce ethane, we need ethylene and reactant and hydrogen gas. For catalyst in here, we can use PD, PT, or NE and I. So this is transition metal, which is transition metal is very good to used as catalyst because they have multiple oxidation states, so they have ability to lose one electron. And now we will see the mechanism of heterogen and homogen catalyst in faster reaction rate. The first one is homogen catalyst. What happened in their reaction? So when the reactant combine with catalyst, so they will collide each other, but in they will collide each other, and then they will going around in random motion. So if they collide each other, after that happens chemical reaction, formed the product and loosed the catalyst. It's very simple mechanism. Then the mechanism in heterogen catalyst. We see in here the blue one, like a ball, represent for solid phase or heterogenic catalyst, and in the upper side there are two reactants which is adsorbed by the solid. This is the keyword, adsorption process. So the surface will adsorb. So it's just adsorb, not adsorb, not absorb. For adsorption process, we know that it's go inside something, like the stuff going through the substance. But for adsorption, it's just going through the surface, just happen in the surface. So the first mechanism, the reactant molecules diffuse to the surface of the solid, and then jadi reaktan, molekul reaktannya, they are two, ada ethane sama hydrogen gas, dia akan menyebar di permukaan ini, solid ini. Jadi dia akan menyebar ke seluruh permukaan dan akan diserap. Dan when it happens, the solid provides a surface area upon which the reactants are adsorbed. Jadi solid ini memiliki luas permukaan di mana tempat reaktannya itu akan diserap. Kemudian the adsorption in reactant to the surface involves chemical bonding. Jadi ketika dia diserap, terjadilah suatu reaksi kimia. Jadi ada chemical bonding in here, di mana ikatan antara masing-masing reactant itu will weakens within the molecule. Jadi and then it needs less energy to break the bond. Jadi butuh energi yang sedikit sekali untuk memisahkan ikatannya. So and less activation energy. After that, the reactant convert into the product and leaves the surface. Jadi ketika dia sudah break each other, dia akan berubah menjadi produk. Can we see in C form? Jadi akan bergabung reaktannya. Kemudian dia akan membentuk suatu produk di mana when the product is already formed, it will leave the solid surface. Jadi dia akan meninggalkan permukaan dari si solid ini dan akan terbentuklah si ethane at hand. So that's all the material from me. Thank you.